Hello everyone. Welcome to Physics 11 at 11. What we got is the following here. In this first course, or first lecture rather, we're going to go through the different uh, types of units, some shorthand ways for writing numbers, and then I'm going to show you a process for converting from one unit to another, which is going to be useful in this course here in physics and possibly in chemistry as well. Now, I know you'd much rather, probably like I would, much rather jump into and start launching satellites and things like that, but, well, we got to do this first. So let's get at it. Now, so blank by blank, right at the top there. The measurements in physics are usually carried out using SI units. This stands for Système International, which is a French description. For us, also known as the metric system, which we've been using for a while now. Now, within the metric system, there are basic units, and they're listed here, but we got to make sure we have the right ones, the correct ones. Okay, so for the measurement of length, the basic unit is the meter. And the symbol for that is M. For mass, the basic unit is kilogram. And the symbol for that, of course, is kg. For time, the basic unit is second, and that will have a symbol of S. For speed, this will be in meters per second. And the symbol, oh, it just looks like that. Meters per second. For acceleration, this one's going to seem a little strange, but we'll make it less strange once we take a look at it. Okay, for acceleration, this is meters per second squared. And the symbol is exactly that, meters per second with the squared there at the top. Top underneath. 2 to go. We have force, which has the unit of newtons, named after Newton. And so he gets a big N. And then energy is named after Joule. And he's got a big J for that one. So those are units that we'll be using definitely in this course and very likely in future ones. Now, in physics, some of the numbers are very, very big. Distances in the universe, computer calculations a second, gigabyte memories and all that stuff. And then some things are very, very small, size of an atom, different wavelengths and such. So we need symbols for each of these. And, well, we got them. I just got to know what they each represent. So tera, symbol is big T, and this means 1 times 10 to the 12. So in other words, 12 zeros afterwards. So very, very big number. Giga gets a big G, and this is 10 to the 9. Mega, big M, this is 10 to the 6. Kilo, small k, so different than the other ones. But you've seen it in like kilometers and kilograms, small k. This means 10 to the 3, so like times 1,000. Now, these are all the big values, or at least the prefixes for larger numbers. Now we can take a look at the next list, which is prefixes for smaller numbers. Now centi, you've all seen with centimeters given by a C, and then whatever unit comes after there. But number-wise, how much is this? To keep with the exponents, it's 10 to the negative 2. Or as you know, there's 100 centimeters in a meter, so 1 centimeter is 1/100th of a meter. So centi means 100th. Then as a decimal, 0.01 like that. Milli, same sort of style. It'll be little m and something else. Millimeter, milligram. 10 to the negative 3, 1,000th. Or watching the zeros, when you write it out like this, because it get pretty long, 0.001. For micro, getting smaller, we jump to Greek letters. This is a Greek letter mu, like a cat. It's like a U with a tail in the front. So this would be 10 to the negative 6. Could show you the decimals and such, but you can see this is going to start getting long, which is the whole point of doing this in the first place. So I'm just going to leave it there. Little n stands for nano. This is 10 to the negative 9. And then pico is little p. That's 10 to the negative 12. Okay, so just to give you an appreciation of where these come up, pico is inside of the atom, inside of the nucleus of the atom, so smallest of the small. Nanometers, this can come in visible light, like around 700 nanometers, for example. That has to do with the wavelength of visible light. 10 to the negative 6 micro. As you'll see, this starts getting into Formula One race design, precision engineering. This helps get the most out of your motor. And then we get to millimeters, like milli, centi, kilo, regular life. And then for these things, I usually think of computers in space. You know, terabytes of memory, right? Or very large distances between astronomical objects. All right, so those are some of the units that we're going to be using, some of the shorthand, the prefixes we're going to use in order to communicate the numbers and such that we have here in class. Next, we're going to start converting from one unit to the other. Okay, this is an important idea. To do it, though, we need some non-metric units, and in particular, time units. So one of the units we have that's not metric is the minute, and then also the hour. And if you don't know already, you will need to remember that 1 minute is the same as 60 seconds, and also that 1 hour is the same as 60 minutes. We'll need other associations as well, and they'll come up. You'll see how to use them when we work through these next 3 examples. Okay, but how does this process work? Well, I call it the chain method. I don't think it's overly original, but describes what's going on. We're going to have the thing that we're converting, then some converting fractions, and then it'll get us the number at the end. Now, one of the tricks that you need to remember is that from math class, whenever you have the same thing on the top as on the bottom, they divide out and they're gone. You know, officially they're equal to 1, but they cancel out. They disappear. So we're going to use that trick with the units in order to make the ones we have disappear and in order to create the ones that we want. So let's take a look at how to do this. We'll convert the first thing, 165 millimeters. Now, how it works is like this. 165 millimeters. Now, if you look at numbers 1, 2, and 3, those blanks up there, they're just referring to what they say is write the quantity as a fraction. We'll do that when it comes up, but it doesn't apply yet, so left it out. This is what we have, millimeters. I want to convert it to meters. So we have to get rid of millimeters, which means we're going to use this trick. Millimeters on the top and on the bottom, make them disappear. And then we're going to make meters reappear. So, just as I was saying, we have the thing to start with. We're going to do some multiplying. Well, what are we going to multiply by? Well, we're going to use those prefixes that we just looked at. Okay, so millimeters. This is on the top. And so to get rid of it, we're going to have millimeters on the bottom. Because then, just like the numbers, the units will divide out and disappear. So we've made the millimeters disappear. Well, we want to get meters. Okay, well, you might have those prefixes in front of you, but I forget. What I do remember is that there are 10 millimeters in 1 centimeter. So 10 millimeters and 1 centimeter, they're the same thing. And it's a little bit bigger, gets us closer to meters. Now, but we're not there yet. So one thing I also remember is that in 1 meter, there are 100 centimeters. So I'm going to multiply with that fact. But in order to get centimeters to disappear, I have to put this on the bottom. And that forces meters on the top, which is okay. It's where we want to go. To make the numbers work, that 1 meter is the same as 100 centimeters. And now we can work this out and make it and get the correct answer. Because watch, just a reminder with the units. Top divided by the bottom, gun. Millimeters divided by millimeters, gun. Centimeters divided by centimeters, gun. Left with meters, which is what we want. So the only thing left, well, one is to admire that. That was pretty good. But the second thing is to multiply the numbers through now. Okay, so on the top, multiplying fractions, top times top times top. Clearly 165 times 1 times 1 is 165. And include the units. We worked hard to find it, so include that in there. On the bottom, we have 10 times 100, so that's 1,000. There are no units there, they all disappeared. And so this will leave the final answer then of 0.165 meters. In other words, 165 millimeters is the same as 0.165 meters. So the process is, write down what you start with, converting fractions, check the units, arrange the units so that they disappear, and then do careful good work to get a good looking final answer. With all of these, there might have been a shorter way to do it, and I know there was, but I did this way just to show you how to create the chain, how the units cancel out, and then how to get the result at the end. All right, let's try the second example. megagrams. We got megagrams to centigrams. Why? No idea. But this is how it goes. 24 big MG. Multiplying it by something. Something we know. From the prefixes, I remember that mega means 10 to the 6. So I'm pretty sure then that 1 megagram is giving me the same as 10 to the 6 regular grams. So we can use this fact in our conversion fraction here. What goes on the top? What goes on the bottom? Megagrams on the top. We need it on the bottom. So it cancels out and disappears. So 1 megagram like that. On the top, 10 to the 6 grams like that. So the megas will cancel out. We're left with grams. That's close, but still got to go a little bit. Fortunately, I remember that, let's see, C is related to 10 to the negative 2. So in other words, 1 centigram is going to be the same as 10 to the negative 2 grams. So what you need are the exponent rules from before, because we're going to have some exponents showing up when we do this work. So remember, when exponents are divided, or terms are divided, the exponents are subtracted. But getting ahead of ourselves a little bit. Let's put the conversion incorrectly. Incorrectly. All right, so we need grams on the top or on the bottom? Bottom. It's on the top. So we need it on the bottom. Top divided by bottom, gone. So we have 10 to the negative 2. We have 1 CG there. Now, because we got to CG, we want CG, I think this is it. But let's just check the units. Mega divided by mega, gone. Grams divided by grams, gone. Left with centigrams. It's good. Now just the numbers. On the top, we got 24 times 10 to the 6 times 1. Don't forget the units. We worked hard at it. And on the bottom, we got 1 times 10 to the negative 2, which is 10 to the negative 2. So this is where the exponents come in. Okay? You got it. Because they're divided, you subtract the exponents. So this is a trick. I don't want you guys to get an answer of 4 for this. Make me sad. The trick is just to write it off to the side a little bit. Just like that. 6 subtract negative 2. And when you see it, it triggers what you learned from a long time ago. You'd actually just go, beep, beep, put it there. But this would be 6 plus 2, which is, see, 8, not 4. So you then get 24 times 10 to the 8 centigrams. Now, we could write it as a decimal. There'd be a gazillion zeros. That's why we avoid this. That's why we learned this topic in the first place. We could convert it to scientific notation, significant figures and all that, but hey, for today, this is good. We'll leave it like this and worry about that other stuff later on. Okay, so that's 2 examples for you then. We got the first one, converting millimeters to meters. This one, mega to centigrams. Still all along the way. Conversion fractions, eliminating the units, tops and bottoms, and then exponent rules, because you have fractions showing up there, tops and bottoms like that. All right, one more example, good people. This example, the style is going to come up a bit. This involves kilometers an hour, which is our regular lives, to meters per second, which is now our physics lives. So this process is a good one to be good at. Now, this is the situation where you want to write it as a fraction and you want to write it properly. You can leave the style aside, this sideways business. You write it top and bottom. Okay, that's the way to be successful. What comes next? A bunch of brackets, because we got to change kilometers and hours over to meters per second. This one's going to be a bit longer than the other one because of the number of units involved. There's 2 instead of just 1, plus the hours is a bit of work. Same method though, right? Now, let's be clever. Let's go after kilometers first, because we know how to switch that easily. 1 kilometer is same as, I think in the prefixes I wrote it as 10 to the 3, but probably like you, I'm just used to writing it like this. So I'm going to do it like that. Just because. Top or bottom though? Kilometers is on the top. That means we put kilometers on the bottom so that it disappears. Right? Want that gone, divided into 1. So that forces meters on the top, but how many of them? 1,000. 10 to the 3 if you want to continue with the prefix style from before. Okay, so that'll get rid of kilometers, leaving meters, which is good. That's where we want to go. But now we got hours to work with. So I'm going to convert hours to minutes, because I know 1 hour is the same as 60 minutes. But then this is where something unusual happens, right? You got to pay attention to top or bottom. Hours is on the bottom here. So that means in our converting fraction we have hours on the top, which puts minutes on the bottom because of the connection between these two. So it's kind of upside down. Even though it's correct, by the way, right? So 1 hour is same as 60 minutes. This hour on the top can divide by this hour on the bottom. Gone. But we're left with minutes. So we got to get rid of the minutes next. Same consideration. 1 minute, same as 60 seconds. So we put the minutes on the top, seconds on the bottom, the single S that we saw in our first part. And the numbers. 1 minute, same as 60 seconds. That's a 6 there. So let's confirm the units. Kilometers divided by kilometers, gone. Left with meters only. That's good. We have hours divided by hours, gone. Minutes divided by minutes, gone. We're left with seconds on the bottom as we need. So this is correct. And what's left? The numbers. Top times the top, 3,000. And let's include the units because we worked hard at it. The bottom, we got 61 times 60 times 60. So that's 3,600 seconds. You can reduce, do regular fraction stuff if you want. I'm just doing it like this. And when you put it in your calculator, right, you'll see it has a result of something like 0.833 meters per second. So using the chain method, just like the others, original value, conversion fractions from the fact that we know. Put the units in the right place so they disappear. And then some careful multiplying and calculating will get us to the final answer. All right, so I'm going to leave it here with this this topic, and look forward to working with you again next time. All right, take care until then.